In this video, I'm gonna write down the equation for electrostatic force between two charges in terms of their position vectors. So let's say we have a charge Q1 and its position vector is R1, and charge Q2 which is lying at point B and its position vector is R2. So first of all, let's write down the equation of electrostatic force or Coulomb's force on charge Q1 due to charge Q2. So that can be written as F, the force on charge 1 due to charge 2, is equal to 1 over 4 pi epsilon naught Q1 Q2 over the square of the distance. The distance is basically BA, but we're gonna write the magnitude, so that will be vector VA and the magnitude of it and square, and the unit vector that will describe the direction of the force in this direction, because force is going from point B to point A. The force on charge 1 due to 2 in this direction. So see, force over here is in this direction. So that will be represented by this unit vector over here, R21 gap. So now we need to find the value of BA vector and the unit vector R21 and plug into this equation. That will give us the equation for electrostatic force or Coulomb's force in terms of their position vectors R1 and R2. So first of all, let's find out BA. So what we're gonna do, we're gonna use the vector law of addition. So here the vector OB plus vector BA is equal to vector OA, that is their resultant vector. So vector OB is in this direction, BA is in this direction, and the resultant vector is going to be in this direction, the opposite direction of other two. So OB plus BA is equal to OA, or we can say BA is equal to, let's subtract OB from both sides, so OA minus OB. So plug in the values. So vector BA is basically R21 vector is going to be equal to OA, which is going to be here R1, minus OB, that is going to be vector R2, and this is basically vector BA. Now if we know the value of BA, we can plug it over here. But before that, let's find out the unit vector R21, which is basically the unit vector of this vector R21. And from the definition, the unit vector is basically is equal to vector in same direction as the unit vector divided by its magnitude. Okay, so let's say R21 divided by its magnitude. So that can be written as, so vector R21 we all know is equal to R1 minus R2 from here, because that's how we calculated. R21 is equal to R1 minus R2 and divided by the magnitude of R1 minus R2. Alright, so let's plug in these two values, the value of the unit vector R21 and the value of BA from here and here into this equation. So that gives me the force, electrostatic force or the Coulomb force between two charges going to be equal to 1 over 4 pi epsilon naught Q1 Q2 over, so BA, vector BA is R1 minus R2, their magnitude and square, times the unit vector R21, which is this. So R1 minus R2 let's put them in parentheses, divided by the magnitude of vector r1 minus vector r2. So that gives me F12, the force on charge 1 due to charge 2, is going to be equal to 1 over 4 pi epsilon naught Q1 Q2 into R1 minus R2, both are vectors, divided by, so this is a square over here, one more term, so that gives me R1 minus R2 magnitude cube. So that's the formula for electrostatic force on charge Q1 due to charge Q2 in terms of their position vectors R1 and R2. Similarly, we can write the equation for the electrostatic force on charge 2 due to charge 1 is going to be equal to 1 over 4 pi epsilon naught Q1 Q2. The only thing will be different, these two will switch their place, so this will become R2 minus R1. You guys can write that down. Similarly, we wrote this part over here, so R2 minus R1 and the cube of the magnitude. There you go. So electrostatic force or the Coulomb's force between two charges in terms of their position vectors. Alright, thanks for watching the video guys. Please do share and subscribe to the channel. That will help me to make more videos, or thanks for supporting my channel.